So, dear students, welcome to another lecture of control systems. In this lecture, we will be discussing about some numerical problems on block diagram reduction technique. So, in this lecture, we will be discussing two numerical examples which are based on block diagram reduction technique. So, first example is given here. So, in this example, our objective is to reduce this the objective is to to reduce the given block diagram using block diagram reduction technique and determine the overall transfer function. So this is our objective, right? So as you can see in this particular block diagram, so it has an input. So this is the input, right? And then we have the output, and this is the output here. Okay, and this is the feedback, right? This is also the feedback, and this is the forward path. Okay, and this is a summing point, this is a summing point, and this is also a summing point, right? And this is the takeoff point here, right? So this is the feedback point, and this is also the feedback point. So these are the components of this particular block diagram. Now we have to reduce this block diagram using block diagram reduction technique. So the first step that we will apply to this particular block diagram is that we will interchange the takeoff point and summing point behind the block G2. So if we go back to the this one, so here we will interchange these two. So this will be interchanged here, and this will be interchanged here, right? So we will interchange these two. So on interchanging, so we know that when we interchange a summing point and a takeoff point, so we have to add a summing point here. So one summing point will be added here, right? So now this is the modified version of the actual block diagram. Now in this we have got this summing point because we interchanged these two, summing point and takeoff point, right? Then the next thing that we do is we will simplify the feedback loops, right? Now we will see that how many feedback loops do we have. So this is one feedback loop here. This is another feedback loop here, right? So we have these feedback loops, and we need to simplify these feedback loops so that we can get a clear picture of the given block diagram. So when we simplify the feedback loops, as you can see, so we have the this is a feedback loop, so it is H1 here, so this one, and now this is H2, and it is going to this point, and it is going to this point and being added with this one, right? Okay, and then we have this here, right? So we have divided this particular path into two. The first one is that we have taken a feedback loop here, and because it is also going, because a part of it is going to this summing point, and a part of that is going to this summing point. So a part of that is being sent here, and it is added to this one, like RS. Okay, this one. Now, as you can see here, it is minus. Here also it is minus. So minus minus, as you can see, have been replaced with a positive sign. So this is because we have actually multiplied this H2 and H1 here, right? So H1 and H2 are basically multiplied here, right? So now this is how we have simplified the feedback loops. Now if we see this picture clearly, so we have a feedback loop here, we have a feedback loop here, right? And we can simplify this particular part. Okay, but in this also we have a summing point at this point of this part, section. So we have this one, this is a pure closed loop. Okay, so we can simplify this one also. So we need to see which is convenient for us to solve, and then we have to apply the rule accordingly. Okay, now we will eliminate the feedback loop with H1. So now we will try to eliminate first of all this one, this one. So this one will be reduced to a simple block which will have the overall transfer function of this feedback loop, right? Which is actually G1 divided by 1 plus G1 H1, right? So this part will be replaced with this one. So this is how we will get a new representation. So as you can see, we had replaced this one with a single block containing the overall transfer function. So it is here, it is this one, right? Okay, so uh, now this is what we have got, right? Now the next thing that we will do is we'll shift the summing point on the left of the block G2 to its right. Now we will see. Now we have a summing point here, so we can shift the summing point on the left of G2 to its right. So here we will shift it and we will get this one, right? So it is like we have shifted this one to this part, right? And when we have shifted this summing point, ahead of G2, so we will get this one, right? So, this is the representation that we will get. Okay. So now, because when we shift a summing point, from a position before the block to a position after the block, so uh, okay, so we have to multiply, as we can see here, this is H2, so we will multiply it with G2. Okay, this is what we have done. Okay, so when we shift, right, when we shift a summing point, so we have to this is the summing point and we have to multiply this with G here, right? So this is how we do, this is how we simplify the block diagram. So this is what we have got, right? Now we can interchange these two summing points. We can simply interchange these two summing points to get a more simplified version of the block diagram. So when we interchange these two summing points, so we will get a possibility to add the blocks, because now if you see here, these two blocks are in parallel to one another. These two blocks are in parallel. So they will be added. So that means we can replace this with a single block containing G2 plus G3, right? So we will get this one. So now this is what we have got. If you see, we will replace this one with this one. And this is a feedback loop, right? This is a feedback loop, as you can see. Now, because this is a feedback loop, the gain of this path is 1. So this will be replaced. This part of the block diagram can be replaced with a single block. It will contain 1 upon 1 plus G2H2, right? So this is what we have, right? Now you have this one. Now in this, you can see these all are, cascaded one another. These are cascaded. These are the cascaded blocks, right? These are the cascaded blocks. So these all can be replaced with a single block that would contain the product of all these three. And then we have this one, because as you see, this is a positive feedback. This is a positive feedback here, right? So this is a positive feedback. So we will be getting, a single, representation in this way, output, and this is H1 and H2, and here it is, both are added. and this is, let us say, A, B, and C, and A is this one, B is this one, for example, and C is this one. So it is A, B, C. So we will get, when we will simplify this one using the feedback concept. So this would be replaced with a single block that would contain, A, B, C, the gain of forward path divided by 1 minus H1, H2, A, B, C, right? So this is what we have here, right? This one. So this is the answer to that particular block diagram. Okay, so this is how we solve, right? We simply have to remember one thing, that when we solve, a block diagram using block diagram reduction technique, we simply have to, see the convenience, right, to apply the uh, rules of block diagram reduction technique. Okay, so we have to, make the things convenient, make the conversion convenient, right? So we shall apply the rule which we find is convenient at some point of time, and accordingly we can solve and simplify the given block diagram, right? So let us move to the next problem. So in this particular example, okay, so this also we will try to understand and reduce this to a single block that would contain the overall transfer function of the given system. Okay, so now in this, we will again apply some rules of block diagram reduction technique. So to apply the rules of block diagram reduction technique, we need to see how we can solve the given, block diagram. So we need to check which rule we should apply to the given block diagram. So as you can see, we have this one, so we can, shift this summing point from here to here, and then we can apply. Okay, then we can interchange the two summing points, because this summing point would come at this point. Okay, so we can interchange these two. This is also we can do, and then G1 and G2 would come in cascade, right? And accordingly we can simplify. This is also we can do, and we should not shift, do anything with this initially, right? So we can shift this to this part, right? Okay, so that would make these two in cascade to one another, and this would be the feedback loop, right? So let us see. So we will shift this one to this part. Now when we shift, okay, when we shift a takeoff point from a point before the block to a point after the block, so we have to multi or divide. Okay, so we have to divide, right, with the given block, right? So as you can see, we are shifting this around G4, around this one. So we will draw this block diagram, right? So let us draw it. So we have all these things here, right? So let us draw and try to solve this one. So by shifting this takeoff point, after G4, so this path, because we are making changes to this path, so this will be divided by G4, because the takeoff point of this path has been shifted to, after the G4, or feedback point, because feedback point is also takeoff point. So we can consider this as a takeoff point also, right? Now, as you can see here, these two are now in cascade. They are cascaded. These two are, cascaded. Okay, and this is a feedback loop. This is a, feedback loop. Now this complete part can be replaced by a single block. So now let us see, now let us, draw the, uh, simplified version of this one. How will we draw? So let us see that. So now, now, because we had shifted, if you see, we had shifted this part to this part, and this was divided by G4 here. So now we will, try to solve this one. So we'll try to draw this one once again. Okay, so we have, this is the summing point here, and then we have a block with gain G1, and then we have again a summing point. Then we have a block with gain G2, and now we, will replace. So we will divide into two parts as of now. So we have this block with G3, and now we have this block with G4, because these two are in cascade now. And now we have this output Y, right? Okay, so this is a summing point and it has the gain. Okay, the gain of this is H2 by G4, and this is the feedback point, and we have one more feedback here with gain H1, and like this. Okay, so this is how the signal is flowing, right? So this is a summing point, this is a summing point, and the gain of this feedback path is H3, and again it is with this one, right? So here we have a positive feedback, so this is actually a positive feedback, right? So now these two are in cascade, right? So what we will do is we will simply replace this one with the single block, right? So let us replace. So we will multiply G3 and G4. Okay, now because this is a feedback path, no, because this is a feedback path, so we will replace this one with a single block, and that would be, what is the, replacement of this one? So we know that the simple formula for this is gain of the forward path divided by 1 minus, because it is a positive feedback, so 1 minus gain of the forward path into gain of the feedback path, right? So that means we will be having G3 G4 divided by 1 minus G3 G4 into H1, right? So this would be replaced, this part will be replaced with this one, right? So let us now replace this one here. Okay, so let us see. Now we will replace this whole section with a, single block. So let us draw it. Okay, so here we have a single block now, and that single block is G3 G4 1 minus G3 G4 H1, right? So, and this one. Now, as you can see, now these two are in cascade with one another. If you see, so these two are actually cascaded to one another. Now, when these two are cascaded to one another, so we can replace these two with a single block, and that would be, so it will be, so we will be, replacing this one with a single block, and this would be G2, right? So this is the single representation. Now, if you see here, another thing that is this feedback loop. So this is also a feedback loop. This is a loop, right? So we will apply the same concept here because, but it is since a negative feedback, right? So instead of taking minus, we will take plus here. Okay, instead of taking minus, we will take plus here. So now this particular part, okay, this particular part will be replaced with a single block, and that would be, okay, so it will be like this. And we have G2, G3, G4 divided by 1 minus G3, G4, H1 divided by 1 plus G2, G3, G4 divided by 1 minus G3, G4, H1 into H2 by G4. So G4 and G4 will be cancelled out here. So we can simplify this one, and when we simplify this one, the resultant block diagram will be this one. So if we simplify this one, we will get this answer, because we will take this as LCM and 1 minus G3, G4, GH, this will be cancelled out, and we have this one here, right? So now, as you can see, these two are in cascading to one another, and then this is a feedback loop, right? And it is a negative feedback. Right? It is a negative feedback. So let us simplify this one also, and let us see what will be the answer. So we simply have, cascaded these two blocks, G1 and this one. So when we cascade these two, we will get this one as a single block. And now we have this as a feedback loop, right? So we will simply apply the same concept here, right? So the concept is that we will take the gain of the, okay, so we will try to solve this one. So gain of the forward path, that is G1, G2, G3, G4 divided by 1 minus G3, G4, H1 plus G2, G3, H2 divided by 1, because it is a negative feedback, so 1 plus, and this one G1, G2, G3, G4 divided by 1 minus G3, G4, H1 plus G2, G3, H2 into H3, right? Gain of the forward path divided by 1 plus, why did we take plus? Because it is a negative feedback here. So 1 plus gain of the forward path into gain of the feedback path, right? And this would give me a simplified version. So I have G1, G2, G3, G4. And now I will take the LCM here. So when I take LCM, this will be cancelled out with this one. And I am left with 1 minus G3, G4, H1 plus G2, G3, H2, right? Plus G1, G2, G3, G4, H3, right? So this is the single block, right? Which will be the answer to the given numerical. Okay, so this is the answer. So this is the overall transfer function of the system, which is given originally here. This is the original system, and this original system has this as the block diagram, right? So this is how we can solve the block diagram using block diagram reduction technique, right? So in this numerical, first of all, we applied the rule of shifting the takeoff point from a position before the block to a position after the block. Then we cascaded, then we applied feedback loop concept. And in this way, we kept on simplifying, and we got the final answer, which is given here. So this is it for today's lecture. Thank you so much. So we will meet with the another lecture, and thank you.